In order to better understand how correlation and regression lines work, we're going to add a few points to a scatter plot and see how it changes things. First thing we're going to do is look at our standard graph here, and we're going to add a point that's very far away from the rest of the data. Not necessarily off the pattern, just far away. So it's going to be the point 7,000 pounds, 13 miles per gallon. And if I had to use my same general scale that I have here to figure out where this point's going to be, it's going to be roughly about this far over, and 13 miles per gallon is going to be probably about this far down. So I'm basically creating a new point somewhere around here, way off the graph. If we go to our calculator and you have the rest of the points from the previous exercise typed in there, we're just going to go to the bottom of our list here, the bottom of our list, and for the weight we're going to use 7,000 pounds, so we're going to add 7,000 as our point here, and then hit enter. Go over, we're going to use the miles per gallon of 13. And now that we have that new point, what I'd like to do is check the slope. I can even check the actual graph if I would like. I can do a zoom 9. Note that you might still have your old linear regression line in there. But you see this new point hanging way out there. But let's look at the details. Let's go to Stat, Calc, fourth one down, Linear Regression. Hit enter right away just to see the numbers. Over on the right here of the screen, I have the original numbers before we added this point, and now here are the new numbers. Looks like our slope very, very slightly got closer to 0, and so did our y-intercept, but no major change. So with that first point, even though it was really far away from everyone else, it still felt very, very close actually to the original line of best fit. Just to check one more thing real quick, I'm going to go back, and I want to see what my R values were. Over here, my R values were negative 0.79 for R, and then R squared was 0.628. Here, it looks like my R value got a lot better, because remember, anything close to positive or negative 1 means a much better fit with the line. So it looks like my correlation actually got a lot better by adding this point that's way out there. Same with my R squared, that's going to obviously follow. So by having this point almost dead on the line, that significantly improved my correlation. Let's try changing it up now. We're going to change that point we just added from 7,013 miles per gallon to 7,000 pounds, 2 miles per gallon. So now it's going to have a horrible gas mileage. We go to Stat, we go to Edit. Clear this here. We're going to go back down to the bottom of the list, and we're going to change that 13 to a 2. So you can just type right over the top of it. Change that 13 to a 2. So now we have 7,000 pound vehicle with 2 miles per gallon. And just to take a quick look at that, to see what the graph is going to look like, I'm going to go to zoom 9 for zoom stat. And I can see that instead of sitting on that line, now that new data point that I just added dropped quite a bit. So it's no longer on the old line of regression. Let's see where it does fit. Let's go to Stat. Let's go to Calc. Let's go down to LinReg number 4. And this time I actually do want to recalculate the line of best fit. I'm curious to see if it's changed. So I will go to vars, yvars. The first one, function, enter, y1, enter, and then enter a third time here. You can see that compared to what I had before I had an a value, a slope of negative 0.003 something. Now I have a slope of negative 0.005 something. And even though the actual number change is not all that significant, that is almost a 2 times, or at least 1.5 times change in the slope. That's very significant. Our y-intercept also made a pretty big change. We went from 37 to 44, so that's a pretty big difference. And with adding this new point, despite the fact that it was way out there and not seeming to fit on our original line of best fit, we actually have better correlation now than we did before. Let's take a look at our graph again. Now that I updated the line of best fit to include this new point, you can see that for the most part, these points actually appear to better fit on the line because that point's so far out there. So it's very interesting. We were able to modify the slope quite a bit by just moving that single point down. We were also able to improve the correlation. Finally, let's change it one more time. Let's change it to 7,000 and then 30. So we go to Stat, we go to Edit, we go down to the bottom of our list 2, change that 2 to a 30, and then we're going to go calculate our, well, let's just look at the scatter plot right away. Let's go to Zoom 9 to see what it looks like. Okay, well clearly that old line of best fit is not going to fit anymore because this point is now way up here. So let's recalculate the line of best fit while we look at our numbers. Stat, calc, fourth one down, linreg. We're going to do our vars, yvars, enter, enter, enter. And this way it's going to recalculate our line of best fit for us in the graph. And if we look at this now, our A value, it looks like it's 9.5 something, but over here we see e to the negative fifth. That's scientific notation. Our A value is now 0.000095. It's almost a flat line. Our slope is almost a flat line towards 0. Significantly, significantly less than what we had before. Our y-intercept went from 37 all the way down to 25 point something. Our correlation is atrocious. We had 0.79, negative 0.79 with the original data. We had improved it with the last 2 points we added. Now we've got it down to 0.04. We have almost no correlation. Let's look at the graph. Zoom 9. Based on the data we had a pretty good pattern going here, and then this thing completely threw it off. Completely threw it off. What we're realizing is that when you have a point that is nowhere near the rest of the pack of data, if you have a point that's a pretty significant distance off, it's called influential. It's because it has a lot of influence. It can change the slope dramatically. It can mess with the correlation dramatically. Just a single point can do that. So when we have that single point like that, we call that influential. When that influential point happens to not fit the rest of the data's pattern, we would also call it an outlier. Any data point that doesn't fit the pattern would be considered an outlier. There's a difference between influential points and outliers. Influential points could include that first point or that second point that made the data fit very well. It made it an almost better fit for the line by having those data values way down there. The influential point just means that it has, if it moves, it has the power to really mess with things. So anything that's far away from the pack, even if it's on the line, would be influential. Any value that does not fit the pattern would be considered an outlier. So that's the difference between those two things. Now we're going to add some different points. This time we're going to actually add points that fit pretty much in the middle of the pack. And we're going to see what happens to our correlation and our slope now. First point we're going to add is 3,000 and 26.68. So if we go back to our stat edit, we're going to actually take out those points we added earlier. So that 7,000, we're going to just overwrite it with 3,000 for the weight. Enter there. And we're going to use the MPG value of 26.68. And the reason that we're using that one is because it happens to fit exactly on the old line, on the old regression line. So if I go to Stat, I go to Calc, go to LinReg, I'm going to want to update my best fit line, so I'll go to vars, yvars, enter, 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 and here is my updated data. Let's compare it to the original data. The slope is nearly identical. For if you include rounding error, it's effectively, the slope has not changed. Same thing with the y-intercept. The y-intercept has effectively not changed. R squared and R both improved a little bit. Here we have negative 0.7925. Here we have negative 0.7949. So that improvement actually is a little bit significant. And the reason that that improvement happened is, let's look at our graph. Let's do zoom 9. The new data value that we added falls exactly on the line. Whenever you add a new point that falls exactly on the line, that's going to improve the correlation, because the correlation is how well do things fit the line, how well do things fit the linear pattern. So the more points that you add right on the line, the more you're going to improve your value for R. Let's change this up a little bit. Let's modify this point so that it's below the line. So now we're going to do 3,000 pounds and 18. We go to our stat, edit, go to the bottom here, and we're going to change that 26.68 to an 18. If we were to jump straight to our graph just to see what this would look like, you actually don't see it on the graph. It gets cut off visually unless we rezoom. So we do zoom 9, and there it is. There is our new value that we just added, significantly below the line. And let's see how that affects things. Stat, calc, fourth one down. We're going to re-update our line of best fit. So we go over to yvars, function, y1, and hit enter. If we look at our A value and our y-intercept, our slope and our y-intercept here, you can see that the slope got a little bit more gradual. A little bit more gradual, and as a result, the y-intercept went down just a little bit. The R value actually got quite a bit worse. Negative 0.79 is not a bad R value. Negative 0.5 is a poor value of R. So if we go to our graph now and look at it, we can see that this point way off below the line actually pulled the slope down. It pulled the whole line down a little bit. That's why our slope became more gradual. Here, this is a steeper negative slope, but this point down here, think of it like a weight being tied to the line. The farther away it gets, the farther it pulls that line toward it, which is why this slope got a little bit more gradual. Last change we're going to make is we're going to change that point to 3,000 and y value of 36. So we do stat edit. Go to the bottom of list 2. We change that 18 to a 30. 36. We go to stat, calc, fourth one down, linear regression. We do our vars, vars, enter, enter, enter trick. And looking at this data here, we have a steeper slope now. We had negative 0.0035. Now we have negative 0.0041. So our slope got a little bit steeper. As a result, we also ended up having our y-intercept go up. So this is kind of the opposite effect of what happened last time. As far as our R value is concerned, we have a similar effect. The R value once again got worse. We do our zoom 9, we can get zoomed into the graph. Our new value is hanging up here. And what this effectively did is, think of it again as having a string tied to the best fit line. When this data point moves very far away, it pulls up the back end, the left side of this line, which therefore makes the slope a little bit steeper. That's why our slope was a little steeper than the one we had before, because this data point is pulling things up. To summarize everything that we just learned, whenever you add a point to your graph and it falls right on the line of regression, right on the regression line, it doesn't change the slope or y-intercept of that regression line. It fits the pattern perfectly. Why would the pattern have to be updated if it fits so well? So when you add a point right on there, you don't even have to update that pattern. The other thing that it does is it increases the correlation. It makes it either more closer to positive 1 or closer to negative 1. It's farther away from 0. The reason the correlation gets better is if you add more points that fit the pattern, then the value that measures how well things fit the pattern is going to get better. The goal for R is to have everything in a perfect line. So the more things you add in that perfect line, the more it's going to help you. So that's why when you add points on the regression line, right on that line, the correlation is going to go up, but your slope is not going to change. When you add a point away from the regression line, like what we did with these last two, something way below or way above, you're going to make your correlation usually get worse. Not every single time, but the vast majority of the time, especially when you're in the middle of the data, when you add a point that's far away from that regression line, you're going to make your correlation get worse. It's going to get closer to 0. And the reason is that you're creating more data that doesn't fit the pattern. So the more data you have that doesn't quite fit the pattern, the more likely you are to have poor correlation. Thinking on the regression line for the slope, it's going to pull that regression line closer to itself. We saw the example with the 18 here where it pulled the whole regression line down, so it's a more gradual slope. And with the 36 up here, it pulled the whole regression line up in order to have a steeper slope. So that's what was going on here. When you plot a point that's not on your regression line, it's going to pull the regression line closer to itself, and it's going to make your correlation a little bit worse.